Hello students, I'm back with the video 3. So in the previous video, that is video 1, we have learned about reversible and irreversible change, where we have seen number of examples of the same. Then we learned about physical change, where with the help of examples we defined physical change, and also we know now the characteristics of physical change. Then in video 2 we have learned about chemical change, where again we saw a number of examples, and where we have seen how a new substance has been formed, and based on the examples we also have defined it. And as I told you that every chemical change is accompanied by a chemical reaction, so we also know about chemical reaction. We know about the reactant and product. With the example, I have explained you the same. Now today we are going to continue with chemical reactions, where we are going to learn about chemical equations. Yes, let's see chemical equations now. Children, I have already told you that a chemical change is accompanied by a chemical reaction. Okay, now in a chemical reaction, two or more substances called reactants react to form new substance, which is called as products. Okay, so when it comes to a chemical reaction, it can be written in a symbolic representation, symbolic form, which is nothing but the chemical equation. So chemical equation is the symbolic representation of a chemical reaction, you can say, where the symbols of the elements, with the help of the symbols of the elements, the reaction is being presented in the form of an equation. Okay, so again I'll repeat the definition. A chemical equation is the symbolic representation of a chemical reaction. So here if you can see, the reactants are written on the left hand side of the chemical equation, while the products are written on the right hand side of the chemical equation. Now, and a reactant and product are separated by an arrow. So you can see the arrow also in the middle. So if you see here, A plus B are the substances which are reacting with each other, which are known as reactant, and it's been written at the right side of the chemical equation, while C and D are the new substances being formed, which is nothing but the product, which is written to the left hand side of the chemical equation. And the reactant and product, they are being separated by an arrow in the middle. Children, before going to chemical reactions, chemical equations, let's clear the basic part of it. So here are the first 20 elements with their symbols. So now you must be thinking, why am I telling you this? Because when we go for a chemical equation, when we write a chemical equation, we basically use these symbols, then the formulas of the compounds. So just wanted you to know that there is a periodic table which contains more than 118 elements. These are the first 20 elements. So here the first element is hydrogen, which is being represented by a symbol H. The second element is helium. It is being represented by He. Okay, now if you see, the first letter is always a capital letter and the second letter is a small letter. So this way the elements have been given their symbols, and with the help of this symbols we are also there is a method of finding out the formulas for the compounds also. We are not going to go in deep, but just wanted you to know that there are elements and the symbols are being used for writing the chemical equation. And also we have already seen that what is chemical equation. It is the symbolic representation of the chemical reaction. Okay, these are the few radicals which are also being used when you need, if you want to write any compound. So basically radical is a group of atom of same or different elements combined chemically that act as a single unit with a positive or negative charge. Okay, for example, you want to write ammonium chloride. So ammonium, the symbol or say the representation is NH4. Okay, and chloride is Cl. So ammonium chloride can be written as NH4Cl. So it's better that we have this list, so it becomes easy to remember the or to make the formulas of the compounds. Okay, now let's see the chemical equation, how it has been written. I'll be first telling you the chemical reaction. So when green colored copper carbonate is heated strongly, a new substance is formed, that is copper oxide, which is black in color, with a colorless carbon dioxide gas. Now this is what is the reaction. This reaction is being represented in the symbolic form. If you see the first example, okay, CuCO3, that is the formula for copper carbonate, where Cu is the symbol of copper and carbonate is been represented by CO3. So CuCO3 is copper carbonate, where you have one atom of copper, one atom of carbon and three atoms of oxygen. Okay, so when CuCO3, that is copper carbonate, is being heated, new substance is being formed, that is copper oxide, which is black in color. So CuO, again Cu is copper, O is your oxygen oxide. So CuO is the symbol formula for copper oxide. Okay, so new substance, that is copper oxide, which is black in color, is been formed with the liberation of a colorless gas, that is carbon dioxide. I hope everyone know how carbon dioxide has been represented, CO2. Now again one atom of carbon, two atoms of oxygen, that is your carbon dioxide. Okay, now if you see it's when it's oxide, it's one oxygen. When it's dioxide, it's two oxygen. So in this way the chemical reaction is being represented in the symbolic form. CuCO3 when heated gives you CuO, that is copper oxide, plus gas has been liberated, which is the carbon dioxide gas. Okay, am I clear? Let's see the second example. When white crystals of lead nitrate are heated strongly, lead oxide is formed, which is yellow in color, with a reddish brown nitrogen dioxide gas, and also oxygen gas has been liberated. Okay, so here white lead nitrate can be represented, or its formula is PbNO3, and that NO3 is the nitrate group. So this 2 goes for both nitrogen and oxygen, so it is outside the bracket. So this is the formula for white lead nitrate, or say lead nitrate. So when lead nitrate is heated, a new substance, lead oxide is formed. Again, if you see lead oxide, PbO. So Pb is your lead, O is your oxygen, that is oxide. So lead oxide, which is yellow in color, along with the liberation of reddish brown nitrogen dioxide gas. Again, nitrogen dioxide, NO2. N is your nitrogen and O2 dioxide, nitrogen dioxide, NO2, along with the liberation of oxygen. So oxygen is again a molecule. It always exists in the form of a molecule, that is O2. So I hope this is clear, and when you have a chemical reaction in this way, you can represent it in the symbolic form. Let's stop today's, children, and let's revise quickly what we have learned today. So at the very first, we have learned about chemical equation, which is the symbolic representation of chemical reaction. Okay. Also, we have seen that every element has its symbol. So if you go back and see, you have the first 20 elements with its symbol. So you can just go through it then. Also, we have seen that these symbols and formulas of the compounds are used to make chemical equation. Okay, and lastly, we have seen the examples of the chemical reaction, where we actually saw how the chemical equation is written for that particular reaction, right? Down I have mentioned a link which gives you more detail about the chemical equation. It actually tells you about balanced and unbalanced equation. So I request all of you to watch it carefully so that you can learn more about chemical equation. Thank you.